Hello, guys. Welcome. Those who are watching this session, a warm welcome to each and everyone. A very warm welcome to each and everyone. Those who are watching this live stream. Okay, we'll wait for some minutes for everyone to join. Till then, I'll just share what we are supposed to do today. Okay, we'll wait for some time. Okay, so before starting, I'll just introduce myself. My name is Sanjeev Das, and I'm going to teach you all atoms and molecules. In the last live lecture, we saw what were atoms, and we had a bit of explanation about what is atoms. In this topic, we'll learn more about it. Good evening, everyone. Good evening. Hi. A warm welcome to each and everyone. Yeah. So we will be learning about what is atom, and as the description or the title suggests, that we are going to learn how were atoms actually named, and quite a few of them are quite interesting actually. So before that, let me just let you all know that welcome to Letstute. A warm welcome to each and everyone. We have a website called www.letstute.com. You can check amazing videos, video content on science as well as on math. The link is in the description, and also you will find the links in the comment section, like on the comment. So you can just go and check it on the website. And don't forget to press the bell icon to never miss an update from us, and also do subscribe to Let's Tube not to not miss any of the live sessions which we are conducting. Hello everyone. Yeah, good evening. Okay, so let us quickly just take an overview what we did the last time. We saw that how atom were actually named. So there was this Indian sage Maharishi Kannad. He said that there are some padarth which cannot be divided further into smaller particles. And then there was a Greek philosopher, Democritus. So he was the one to name these small particles as atoms. So we have the smallest particle named atom because of him. Then we saw how two very important laws, that is law of chemical combination, which were introduced by Antonio Lavoisier. He was the one to propose very important two law of chemical combination, that is law of conservation of mass and constant proportion. These are very important two laws which can be asked for your exams. Also, other than that, we learned about Dalton's atomic theory, the six very important statements which Dalton mentioned in his atomic theory. But today we are going to learn how these atoms were actually named. But before that, let's quickly polish or brush up a few knowledge about atoms and something about elements. Okay, so as you can see, this is a big mansion, a big house. But if you notice this house or any building or complex carefully, you'll find that all of them are made up of tiny or small bricks. Like small structures of bricks make them humongous structures or a massive structure of these mansions. If you see these ant hills, these ant hills are made up of very small grains, that is sand particles. And if you notice, this is a Lego structure, a huge structure of made up of Lego cubes, Lego blocks. Actually, it's made up of Lego. So everything, whatever we are seeing, are made up of small and tiny objects. But the question is all of them same? Are the atoms different of different objects. Like my question is the atom of this brick, this sand, and this Lego cube different or they are same? Suppose if I have this presenter, it will have presenter atoms. Suppose if I have some plastic, it will have plastic atoms. So if we consider, there will be a lot of atoms in this whole universe. Uh, are we made up of cells for atom? I have doubt for many years. Of course, we are made up of atoms. Our cells are made up of atoms. This I have discussed last time that we are made up of atoms. In fact, everything is made up of atoms. So I hope that doubt is clear that everyone, everything, and every object is made up of atoms. So similar to that, everything is made up of atom, and we can't have varieties of atoms, right? So when many atoms combine together, they form new compounds. Suppose if there are atoms for cement bricks, there won't be cement atoms or plastic atoms or sand atoms. There will be some atoms which combine together to form this sand compound or cement compound or plastic compound. So many different atoms combine together to form new compounds. But we should know that there are only 118 known elements. That means there are only 118 unique element atoms present in this universe. This whole universe is made up of only 118 known elements. They combine together to form huge structures, small structures, various different types of structures. So, for example, if we have if we want to write all of them equations, suppose in this equation, this is a pure atom, like hydrogen. H2 is a molecule of hydrogen, of course. So H2 plus O gives us H2O. So this is a molecule. We'll learn more about molecule in our next chapters, in our next videos actually. But for now, hydrogen plus oxygen gives us hydrogen and oxygen. But why are we writing it in this format itself? Why can't we write it simply as 2 hydrogen plus oxygen gives us 2 water? Why can't we write it in this way? Like as you can see, if I write words instead of symbols, it actually fills up the whole space. Like it's very space consuming. So scientists came up um, with some tricks. They thought that we should use symbols instead of writing the whole words of the elements. So, so instead of writing the whole word of the element, symbols were used. But a point to be noted is how did they come up with these symbols? How did they come up with these symbols? Or actually, my question should be, how did these name actually come up? How did this hydrogen word or oxygen word actually come from? So to answer that question, atoms or elements were named, or the names were after various of things. Suppose for example, one of the major thing was that elements were named after the places they were found in, like Cyprus. So this is an island. This island is abundant of a lot of metal, and that metal was named as cuprum. This cuprum later it was named as cuprum. So this was the name. So it was from cuprum to cuprum to copper. So this was the change in the name. So copper is actually named after an island. So the elements were named after the places they were found in. Suppose if we take for example germanium, it is named after Germany, the place it was found in. Similar to that, copper is also named after the place it was found in. Next example is Elements were named after their properties. So whichever atoms we are looking at, everything. Okay, so some kids are asking what does atom word actually mean. So let me just quickly explain what does atom mean, then I'll just quickly jump back to this. Atom simply means that a means not and Thomas means to cut. Actually, it's derived from a Greek word atomos. Atom is derived from a Greek word atomos, where A means not and Thomas means cut. That simply means that atoms are indivisible. This atom word itself means that it's indivisible. So let's quickly jump back to this. How were elements named after their property? So, for example, gold. In English, gold simply means yellow. As you can see, this gold is yellow in color. So it was named after its property. That gold was named actually after its property because it was yellow. And one more name which it had is aurum. And what does aurum means? Aurum simply means to shine. Gold shines very beautifully. So aurum simply means to shine and gold shines. So it is named after its property. It has two names actually. It has gold and aurum. So for writing the symbols, we use aurum as its name. This is the scientific name for gold. Please keep in mind while writing. Okay, so we'll discuss about it while writing the symbols, but for now, elements were named after their property. The first point was element were named after the places they were found in. Second is the elements were named after their properties, like which kind of property they had. One more example is argon. Argon is an inert gas. As we know, argon is an inert gas. But how did this word argon came? Argon simply means lazy. Now, why did we call argon? Why did we call argon as argon, or why did we call him lazy? Because it didn't react with any other element, because it had completely filled octet. As you can see in the diagram, it has completely filled octet. Now we'll discuss about octets in the later videos. Of course, I'm saying these things, but if you want more details, you can check our website. Our website is www.letstute.com. In that, you will find amazing videos related to them, and you can like progress faster. But we will discuss them in the live sessions, of course, in future live sessions. So argon has completely filled octet. So therefore, it's a lazy element. So the name argon is lazy. Okay. Next is the elements were named after the scientist. In honor to them, elements were named after the scientist. One of the element is named after Albert Einstein. Einsteinium. This atom or element is named after Albert Einstein. One more atom which is named after a famous scientist, that is Niels Bohr. An atom is named after Niels Bohr, and that atom is named as borium. So borium is named after Niels Bohr, and Einsteinium is named after Albert Einstein in honor to them because they were amazing and great scientists. And the next one is elements were named after planets. Of course, as we can see, there are many elements which are named after planets. One of them is Mercury. Mercury is a planet, and Mercury is also an element. As you can find Mercury in your thermometer. We had a Mercury wala thermometer. It had a Mercury is a silver color metal which is actually liquid, liquidish in liquid, yeah, liquid in state actually. So Mercury is element name and also a planet name. The word Mercury is taken from planets. One more element name which is taken from planet is uranium. Uranus is the planet from which this word is taken. This is the element which we are talking about, uranium. So this one is actually my favorite. This one is actually my favorite. This one is about fictional characters. The atoms or elements were named after the fictional characters. And this is what this part is which made me amazed. Like, how can scientists name anything after a fictional character? But actually, atoms are really named after some fictional characters. One of them is this character. As you can see, this is a character from Avengers movie, but of course, it was from the Greeks' time actually. He is Lord of Thunder, and he is Thor. Yeah, so atoms are also named after fictional character, and this fictional character is Thor. And there we have a atom or element named as thorium. Can you imagine, like, atoms named after fictional characters? This is where chemistry actually excited me, that it is named after fictional characters. So thorium is the one which is named after fictional characters. That you can note it down actually. Now coming back to hydrogen and oxygen, how were hydrogen and oxygen named? This word hydrogen we can bifurcate into two different words. One word is hydro and the second word is genus. So what does hydro means and what does genus means? Hydro simply means water. Hydro simply means water. And what does genus means? Genus means to form. That simply means that hydrogen is derived from a word which simply means water forming. Hydrogenous, water forming. So hydrogen means water forming, as it is used in the equation to form water. H2 hydrogen plus oxygen gives us water. Hydrogen is used to produce water, therefore hydrogen is named as hydrogen because it is used in forming water. Now you'll say, then what is oxygen named after? So yeah, if you divide this oxygen word also, if you divide this word oxygen, you'll get two different words, that is oxy and genus. Gene, oxy and gene. We know what does gene mean. That simply means forming. What does oxy mean? Oxy means acid. Oxygen is acid forming element. Whenever it reacts with any other element, it forms acid. So oxygen is known for acid forming. So it is named as acid forming. So oxygen. I hope you will remember these few tricks and yeah, like tricks to remember how they were named actually. So let's quickly once more just go through all the slides which I showed you. Let's start with how elements were named. So elements were named firstly from the places they were found in. So copper is one of the examples. So cuprum is the word which is used for copper. Okay, and the place it was found in was Cyprus. Okay, so remember this word Cyprus. It is a island which it was found in, abandoned. Okay, so copper is named after an island. Elements are also named after their properties. So gold is named after its property, that is yellow means gold means yellow because it is that is its color. And the next thing which it is named after is aurum. And what does aurum mean? We know that aurum simply means to shine. Okay, so and yeah, how is argon named as argon? We discussed that argon means lazy, and argon is a lazy element because it does not react with any other element. So argon is named as argon because it is a lazy element. Next is that elements or atoms were named after the scientists in honor to their name. So atom are also named after Albert Einstein, the atom named as Einsteinium, and the next atom which is named after another scientist, Niels Bohr, the atom name is borium. Atoms were also named after the planets. One of the planet is Mercury. So element is named after planet Mercury, and also one more element is named after a planet, that is uranium. Uranium is named after Uranus. Okay, this one is my favorite. Please do remember this and also post it in the comment that do you like this one? Fictional character Thor. So atoms are named after fictional character. One of the atom is named after Thor, and the name of that atom or element is thorium. Please do remember this. Okay. And how is this word hydrogen formed? Hydrogen is formed from two different words, that is hydro and genus. That simply means water forming. That simply means uh, water forming. Okay. And what is the next element? The next element is oxygen. And what does oxygen mean? Oxygen is also divided into two parts. Remember, please. Oxygen is divided into two parts. That is oxy and gene. Oxy and gene. And what does oxy mean? Oxy means acid and gene means forming. So that simply means oxygen means acid forming. Is that clear? So let's answer the question, why are we naming them, or why are we using or why are we naming them, or why are we going to use symbols in place of the whole big equations? Like we could have just simply written words that hydrogen plus oxygen gives us two water. Why didn't we use that? Why are we focusing so much on using some symbols? So a clear answer to this question is actually convenience. It is very convenient to use symbols in place of words, because a name of an compound can be very long. As you can search which is the longest element or compound named, you can search it in the Google. You'll find it that it's very long. So we use symbols in place of elements. Sorry. So we use symbols in place of name of the elements. So it is for the convenience purpose. So now the question is what we can use in place of the elements. We know we are going to use symbols, but which symbols? So Dalton to the rescue. As Dalton came for atomic theory to the rescue, Dalton again came to the rescue. So Dalton to the rescue, he came up with some of the symbols which we could have used for writing the equations. So this circular thing, the hydrogen was used as single dot for hydrogen, for carbon, for oxygen. So these are the various symbols which he proposed to be used in the chemical equations. But look at them. As we discussed, we have 118 elements. So try to imagine, if you're given a task to remember all the pattern of these elements and there are 118 elements, will you be able to remember them? Won't it be very difficult? So remembering all these diagrams of the atoms or the symbol for the atoms were very difficult. So one more person who came was Berzelius. So he was the one to suggest that we should use some alphabets to denote symbols of the elements. Like for hydrogen we should use H, for oxygen we should use O, for carbon we should use C, for neon we should use Ne. So these were some examples which I'm talking, but he was the one to suggest that we should use alphabets or letters instead of drawing these structures or drawing these symbols. So for symbols, we will be using letters. So how were they named, or how were they symbolized during that time? So it was divided into three parts. Okay. So first part was the elements were named after their first initial letter. Suppose for if we talk about hydrogen, as you can see, the initial letter is H. So the first letter was used for its symbol. Next example is about oxygen. the first letter of the oxygen is O. So O was used for symbol of oxygen. But what was the second method which was used? First and the second words of the element was used for the symbols. Now what do I mean by that? For helium, as you can see, for helium, first two letters were used. So first two letters were used for writing the symbol of helium. As you can see, neon, as I discussed, neon. So for neon, Ne was the symbol which was used. Now very important thing which every kid should notice and should follow, that the first letter is capital and the second letter is always small. Please remember, the first letter will be capital and the second letter will always be small. Okay, so these were two examples. There was more examples. So copper is the symbol for copper we use is Cu, but it isn't taken from the word copper, but it is taken from this word cuprum, and we know that copper is also known as cuprum. So cuprum is the word which was taken for copper, and its symbol is Cu. You can see for copper, the symbols we use for copper is Cu and not Co. Please remember, the symbol we use for copper is Cu and not Co. The first letter should be capital and the second letter should be small. The third example was of ferrous. As you can see in ferrous, the first letter is F and the second letter is E. Both of them were used to symbolize ferrous. And what is ferrous? Ferrous is a name for iron. You can find the scientific name for iron is ferrous. So scientific name for iron is ferrous. So Fe is used for representation of iron. What is the third method? So first and any. What does this first and any mean? Suppose if I have an element named magnesium. So the first two letters are M and A. The first two letters are M and A. But as you can see, the symbol used is M and G. So the third method which was applied was the first letter will be used and any other letter can be used from the name. So to symbolize the element, first letter and any other letter from the element was used for the symbol. The rules remain the same, that first letter should be capital and the second letter should be small. The second example is about magnesium. As you can see, the first letter is M and second letter is A, but we are not using A for the symbol, we are using N for the symbol. So the symbol for magnesium is Mn. So just try to follow. This is a periodic table. This is a modern periodic table which has 118 elements and their symbols. This 118 elements and it has all the symbols which we are going to use. So hydrogen, helium, lithium. So each and everything you can find it over here. So this is for carbon, this is for oxygen, this is for nitrogen, this is for neon, chlorine, sodium. So there are all the possible elements which can be listed. So in nature, in present there are 118 known elements which are found. Okay, so this is a modern periodic table which you will learn. So how were these elements or how were these atoms actually weighted, or how were their mass determined? So remember, atoms are very tiny. Atoms are very tiny. So just try to imagine, if I want to weigh this small tiny particle, it will be so difficult to weigh this small particle. And as we have 118 elements, it will be so difficult to weigh everything. It will be so difficult to weigh 118 elements. So what can be the method used? But before that, just let me tell you, we have amazing courses on science and math in our website, that is www.letstute.com. You can find the link in the description, and also in the chat box you can just click on the links and just go through the courses, and they are really amazing. So do check. Don't forget to subscribe our channel and also press the bell icon so that you will be updated with the live sessions which we are providing. Okay, so let's quickly start whatever I was saying, that weighing a single atom is like it's so difficult. So weighing all the 118 atoms will be like it's so difficult, right? I'm sorry, I shouldn't be like joking about this, but yeah, weighing a single atom is so difficult, and imagine weighing 118 elements will be so difficult. So, what was the method used by the scientists? So, relative atomic mass was the method which was used by the scientists. And what is relative atomic mass? So if we have an equation, we know that how much mass is used, how much amount of hydrogen or how much amount of oxygen is used for an particular equation. So suppose if I have an equation in which I am supposed to produce or make 9 grams of water, I'll use 8 grams of oxygen and 1 gram of water. So what is the proportion between hydrogen and oxygen? As you can see, this is the proportion between hydrogen and oxygen. The next example is about carbon monoxide. So carbon and oxygen reacts together to give carbon monoxide. So 7 grams of carbon monoxide is formed from 3 grams of carbon and 4 grams of oxygen. Please remember, this is a very important formula which we are going to use. So this is the ratio between carbon and oxygen. This is the ratio of their mass. Okay, so if I take this oxygen on the right hand side of the equation, so carbon will be equal to 3 by 4 into oxygen. So this will be the equation which is formed. Now, so scientists came up like, if we find out one weight of, if we struggle and find out weight of one element, we can easily find out weight of the other atoms, of course. So in this example, if I get to know what is the atomic mass, what is the atomic mass of oxygen, with this equation I can easily find out the atomic mass of carbon. Please try to understand what I'm saying. If I know what is the atomic mass of oxygen, I will be able to easily find out what is the atomic mass of carbon. So this method was used. The relative atomic mass property was used to determine all the atomic mass of all the elements, the 118 elements. The weight of the atomic mass of all the 118 elements were determined using this property, the relative atomic mass property. So suppose if I have weight atomic mass of oxygen as this, that is 2.65666 into 10 raised to minus 26 kg. Remember, 10 raised to minus 26 is a very small number. So this is the atomic mass of oxygen. Then what will be the atomic mass of carbon? We just quickly substitute this value into this equation and we try to solve it. We will get to know that the value of carbon is this. And when scientists found out experimentally what can be the value of carbon, they found out that the value of carbon is exactly equal to this value. So they were quite amazed by this property and they used this property to find out all the 118 elements ka values. So these are some of the atomic mass which was found out by the scientists. Actually, they found out weight of every element. So these are some of them. That is hydrogen, helium, lithium, beryllium, boron. These are some atomic masses. But as you can see, the numbers are quite ugly. And what do I mean by ugly? Actually, that it's scary. It has so many points and so many digits in it. Can it be more simpler? Like, can we have a conversion factor for atoms? Can we have a unit for the mass? So yes, scientists came up with unit, or for the mass of atom, and it was named as atomic mass unit. So the unit of the mass was named as atomic mass unit, and now it is actually named as unified mass. So we will be using this letter small u to denote that it is a unified mass of the particular atom. So how much is this unified mass, or how much is 1 u equal to? So scientists had to decide a conversion factor, or they had to decide a standard measurement which can be used to compare all the different elements. So scientists decided that oxygen can be used as the standard element to measure the weight of all the other elements. And what do I mean by that? So oxygen reacts with almost every element, so it is easy to find out the standard unit and the ratio between them. So suppose if the value of oxygen is this, that is atomic mass of oxygen is this, and the unified mass was equal to 116, that is 16 times lesser to this value was the value of 1 u. One unified mass was equal to 1 upon 16 into 2.6566 into 10 raised to minus 26 kg. And now how much is this value? We'll find out that 1 u was actually equal to this. But in 1961, a standard unit was used, that is carbon 12. So instead of using oxygen, scientists started using carbon 12 uh, as the standard measurement to measure all the atomic masses. So for oxygen it was 1 upon 16, for carbon it is 1 upon 12. So to find out what is the atomic mass, the unified mass for carbon 12, it is 12 u actually. But what is the value of 1 u? It is 1.6605 into 10 raised to minus 26 kg. This is a very small number. So suppose if I know what is the unified mass of one element, if I know what is the unified mass of one element and I know what is the conversion factor between them. So suppose if I have this equation that 2 hydrogen upon oxygen is equals to 1 by 8, and I know what is the value for oxygen. The value for oxygen is 16u. The unified mass for oxygen is 16u. What will be the unified mass for hydrogen? So we quickly substitute it in the formula. We get it by solving the formula that hydrogen equals to 1 upon 2 multiplied by 18 multiplied by 16. If we calculate it properly, we will get to know that the unified mass of hydrogen is equals to 1. And we go back to the slides, we'll find that it's exactly that much itself. The atomic mass of hydrogen was 1.008, and we got the unified mass as 1 u, that is unified mass. So it is exactly equal to 1. So this is a very important point which should be noted. And one more important point which can come for your exercise or problems. Actually, they'll ask you what is the atomic mass for chlorine or any other element, and they will give you the unified mass. Like for suppose if they have given you the unified mass for chlorine, it's 35.45 u, and you're supposed to find out the atomic mass of this particular atom. We know that if we multiply this unified mass with the value for one unified mass, that is 1.6605 into 10 raised to minus 26, we will get the exact value for this chlorine. We will get the atomic mass for chlorine. So that's it for this session. That's it. Yeah, let me just address the comment section, those who have written it. So yeah, hello guys. was very tough. No, it's actually easy. If we try to understand the concepts, it is really well. Subscribed in the previous chemistry. Thank you. Welcome to everyone. Yeah, let me just quickly remind you once again that uh, Letstute has an official website named as www.letstute.com, and you can check some amazing content over there about science and math, and you can just go and check it out. Yeah, it's fun actually. And don't forget to subscribe our channel. Don't forget to subscribe Let's Tute, and don't forget to press the bell icon so that you don't miss any of the live sessions. And there are many live sessions going on our channel. So be tuned to follow them. Okay, so that's it. If you have any questions, you can ask it. Let me just quickly brush it over what we did. We learned about what is atomic mass, what is atomic mass for atoms and how are they calculated, what is one unified mass equal to, and we have also studied what is relative atomic mass and how are the elements named, why were they named, after what were they named. And one of the favorite thing which I loved was, of course, thorium, and they were named after scientists and the places they were found, and also after their property. So that's it. That's basically what we did in this whole chapter, in this whole video. Yeah. So yeah, that's it. So those who are watching this live session, thank you so much. Thank you so much for watching it. I hope you did learn some of the unknown properties which nobody actually talks about, how atoms are actually named. Okay, so that's it for this session. While concluding it, I'll once again say please do subscribe to our channel. Don't forget to press the bell icon to never miss an update from us. Also, we have a lot of courses on our website, that is www.letstute.com. So do check it. Okay, so bye guys, have fun. Bye.